Okay, welcome everybody to another live stream. Back at you again to go over some homework problems, and I am doing some kind of weird things today. I have some other stuff going on my computer, so hopefully the sound and clarity and everything is working all right. Again, what we're going to do today is kind of cover trigonometric word problems. In my class for pre-calculus, we are now in the applications of trigonometry. So what we're going to be covering in the next couple weeks is, the law of sines, law of cosines, and then looking into vectors as well as parametric and polar equations. So if that's something that you are going to be covering in your class or you're just interested in it, those are some things that I will be discussing in the next couple live streams here for the homework as well as quizzes. So I see a whole bunch of you guys have joined in. Zarif, you are the right comment, first comment. Good job. Avery, Wolfie, Maddie, Eva, and Shoho. Awesome. Good. Glad you guys could go ahead and join for a live stream. And then hopefully everything is not too bad. If the clarity or my stream quality does start to slow down, just kind of let me know, because I did kind of take off the restream for going from Facebook as well as to YouTube. So I'm just doing YouTube right now. I'm also going to try to pick up this live stream a little bit, make it go down a little bit quicker. Just because, a lot of my live streams been going to like an hour, and I'm going to see if we can try and maybe condense this around to 45 minutes. So I did ask some questions, but nobody asked any questions on there. So I'm sure there'll probably be some questions that'll come in throughout the live streams, and if I have time, I will try to answer those in the end. But just a reminder, guys, I do want to kind of get a little bit more forward. A little bit better scheduling for my live streams. So at least on my Facebook page, Free Math Videos on Facebook, I will at least try to schedule out my live streams as, at least a day in advance. So therefore you guys are aware when I'm going to go live. And therefore, if you have some questions or topics you'd like me to discuss, you guys can just go ahead and ask them for them. So, either way, we will, go ahead and get started from there. So, good to see you guys. That's all right. Looks like Guillermo, if you're in Algebra 2, a lot of the stuff that we cover here is, at least in the pre-calculus, a lot of my live streams is, even though it's in pre-calculus, a lot of stuff is from the Algebra 2. So, definitely a lot of the stuff that we'll be covering then. However, in this chapter right now, this is not really going to be seen in Algebra 2, the applications of trigonometry, but definitely some stuff that you hopefully should remember from geometry and, maybe into some other classes you'll be covering. So, all right, now, just to kind of give you guys a little heads up, I did kind of play around. This is not usually a section that is found in applications of trigonometry. Typically, this section is taught with trig, but since we are allowed to use a calculator for this one, I kind of combined all of those calculator assessments into one chapter. So that's why I've kind of moved this one over to there. So we're going to be doing some basic trigonometry in this problem. Nothing kind of crazy, but you can obviously see now that we're talking about some word problems here. So that's usually where students kind of get stuck on all of these. So awesome to go there. So let's go ahead and get started. Again, guys, keep the questions here as you guys have them, and then what I'll do is I'll try to work back in the chat and come through. But before I get started, I got to take a quick break because I forgot I put my dog outside and I forgot to let her in before I get started. So I'll be right back. Okay, let's get started. All right, so the first one says a ladder 20 feet long leans against the side of a house. Find the height h from the top of the ladder to the ground if the angle elevation of the ladder is 80 degrees. And I apologize, I know you guys can read. I think I just like reading them out loud for my own brain to kind of like internalize what exactly is going on. So again, all of these problems here, guys, these are all going to be based off of right triangles. So every single word problem here, I know I'm going to need to create a right triangle. So what I told my students to do is, just draw a, random picture. So you have a 20-foot, a ladder 20 feet long. So we have a nice little ladder, leans up against a house. So that's 20 feet. And here you have a nice little house. Right, and there, so you have this nice little ladder. and it says the height h, so that's what we want to figure out is the height h, from the top of the ladder to the ground. If the angle find the height h from the top of the ladder to the ground if the angle of elevation is 80 degrees. So again, remember, angle of elevation is going to be angle above the horizontal. All right, so that's going to be 80 degrees. So then based on this information, guys, we basically have a triangle that we are trying to find. So we have a 80 degrees. That's going to be a right triangle, right? Because you have this perpendicular height. And then we have 20 feet. So using our trigonometry, we can see that we can set this up as being the sine function. So I can say the sine of 80 degrees equals h over 20 feet. Now, I do apologize, guys. I did download my TI software, so I could go ahead and show you guys what I'm typing, how to type it in. Even though you don't need a TI, you could use any scientific calculator would work. But I unfortunately put on an external drive, and I left that at school. So I am going to be just typing in the problems into my own calculator, and hopefully you guys can verify your answers. So therefore, h is going to equal 20 feet times the sine of 80 degrees. So even though I did kind of work these out just to make sure they were all right, I am going to go ahead and type this in one more time. And then I did not say what to round this to, so therefore I'm just going to round this to the nearest thousand. So h is equal to 19.696. All right, and again, you can have h here, so you can either define h, what I've told my students. So h equals, the height from the top. Since you can see here, it's defined. Actually, in this case, we already have h here is defined. So it actually tells you what h is defined as. So therefore, I'm not going to define it because we're already good. It's already been defined in the problem. So this is a nice problem. Typically, when you're creating your own variable, we want you to define it. But in this example, they actually defined h for us, so we're good. The next one says an airplane flying 600 miles per hour has a bearing of 52 degrees. After flying 1.5 hours, how far north and how far east will the plane have traveled? So again, we're talking about a bearing. So whenever we talk about a bearing, what I told my students to do is draw your cardinal direction. So draw your north, east, south, west. Okay? So remember, bearings start from due north, and then clockwise is going to be positive. So we have an angle here, and this would be, let's say, 52 degrees. All right? So basically now what the question is asking, after you've traveled this far for 1.5 hours, so you're going 600 miles per hour. So again, let's just kind of think about this. Like if you go 600 miles per hour, so if you travel for an hour, that means you've traveled 600 miles. If you travel for 2 hours, you've traveled 1,200 miles. So if you travel for half an hour, then you've traveled for 300 miles. So, I mean, you could just do 600 times 1.5, and just doing that math here, you'd get 900 miles. Actually, you know what? Let me do it this way. This is really miles per hour, and then times 1.5 hours. Therefore, you can see that the hours will divide out, and you're left with 900 miles. Okay, so we can see that this has traveled 900 miles. I'll just use MI here. And basically now what we're looking at is saying, all right, so after it's traveled 900 miles, like how far did it travel east and how far did it travel north, right? So we can say, let's let this be E and then this be a little n, right? So if I wanted to represent like a trigonometric relationship to figure out n, I have my triangle here. I can basically just say here, let's see, that's going to be adjacent. So that'd be the cosine of 52 degrees equals adjacent over hypotenuse. And if I wanted to figure out for E, solve for E, how far east it went, I would say that's going to be opposite over adjacent. So I'll say sine of 52 degrees is equal to east over 900 miles. Now again, since I didn't provide my calculator here, I'll just show you which I'll write. So therefore I'll say n is equal to 900 miles times the cosine of 52 degrees. And then here, E is equal to 900 miles times the, oh, I wrote that, yeah, that sine. Let's zoom in actually a little bit. So that would be times the sine of 52 degrees. All right, so let's figure out here what n is. So let's do 900 times the cosine of 52. Again, make sure you're in degree form. And rounding to the nearest thousandth here, I would have 554.095. And then 900 times the sine of 52. And that's going to be, oops, I got to write, obviously these are in miles. Make sure you have your unit. So this would be 709.21 miles. Okay? And again, you could either say like the, the plane traveled this far east or north and then this far east. Or I'm just going to just kind of define my variables. So n equals how far east the distance traveled north. And then E equals the distance traveled east. Okay, because I created these variables. So in the first example, they told us what our h represented. So we didn't have to define it. Well, here, we didn't have what n or e represented. I created those, right? Because you could have used x or y's. So therefore, since I created these variables, I just want to make sure that I define what exactly they represent. The other way you could do that is just create a, is just using a sentence here. All right, so, So the next one says, a ship is 45 miles east and 30 miles south of a port. The captain wants to sail directly to the port. What bearing should be taking? So again, we're looking into, I had some students that were kind of struggling with this. And I said, like, just imagine you're on a ship, right? So again, we're talking about like bearings and ports. So let's, again, do our lovely northeast, southwest thing. All right, so here you are. All right, so let's pretend you're on a ship, right? Here's the port. Right here. P is for port. So you're traveling 45 miles east. So, all right, you go this way 45 miles, right? Which is east, obviously. This is north, west, and south. Then the captain turns and you go, 30 miles south. So you go directly, 30 miles south, right? So 30 miles. Let's put an MI here. All right, now basically what happens is now you want to drive back to port. So like, how do you get back to port, right? So the nice thing is you did create a 90-degree angle, which we know is going to happen, and you want to get back to port. So here you are, you're trying to get all the way back here. Now, the one thing we notice is of this right triangle, we can figure out what this angle is, right? That angle is going to be theta. We can figure that out. But again, that's not the bearing. That's not what we're trying to find. But whatever, let's go ahead and figure out what that angle is. So if I wanted to figure out theta, I would say that's going to be the tangent of theta is equal to, opposite over adjacent. So that would be 45 miles over 30 miles. Obviously, the miles are going to divide out, and therefore to undo tangent, we can use the tangent inverse. So therefore, I have tangent inverse of 45 over 30. So therefore, this angle, theta equals, so I'll do second tangent to get my tangent inverse. That'd be 45 divided by 30, and that's going to be 56.31 when I round it to the nearest thousand. So 56.31, and again, remember that's in degrees, right? Okay, so that's not the bearing though. The bearing, remember, when we talked about bearings, we did our notes. The bearing is from due north going in the positive direction. So, like the way that we looked at writing our bearings is this would be the bearing, right? So our bearing is going to be basically 360 degrees minus theta. Or what you could do is you could take this bearing, but just do it as north 56.31 degrees and then west. So it's the north and then 56.31 degrees west. So again, it really just kind of depends on how you're saying. You don't want to say, oh, it has a bearing of 56.31, because a bearing of 56.31 is 56.31 in the positive direction, which is clockwise, and we're going counterclockwise. So to get the positive bearing, we just do 360 minus your theta. So let's just do that, 360 minus our last answer. And if I was going to do it that way, I would get 303.69 degrees. So just very important, just to kind of understand, the way to type of the bearing, especially on a multiple choice, as they could be represented in either one of those, how to do it. But again, the number one mistake students make is they find the angle and they say, oh, that's the bearing. But again, remember, bearing is starting from due north, going in clockwise, which would be the positive direction. All right, I'll go and finish up the last one, and then I will kind of check in with you guys, just kind of see, check in before we get to the multiple choice. So a passenger in the airplane at an altitude of 10 kilometers sees two towns directly to the east of the plane. The angles of depression to the towns are 28 degrees and 55 degrees. How far apart are the towns? So this is a little confusing because you see like the east and you're thinking, oh, this is like bearings again. But actually, we're talking about angles of depression in this case. So it's actually not going to be like the north, south, east, west kind of idea. So basically, like we have the ground here and like you have the plane. And typically on something like this that would be this confusing, you'd probably have a picture, okay? So what they see is there's like two towns. So let's do one town here and then one town there. All right, really bad pictures of towns, but those are the towns. So your plane is 10 kilometers high. I guess I could zoom in now. Right? And then we're just going to say to the east is to the right, right? It really doesn't matter in this case, but you can see the angles of depression. Now remember, when we're doing angles of depression, that has to be from a horizontal line. So I'm going to say that the plane basically is going to be our horizontal, and then going down would be your angle of depression. Remember, angles of depression are below the horizontal, where angles of elevation would be above. So therefore, you can see that I have two angles of depression. So I have this angle of depression, which would be 28 degrees, and then this one, which is going to be 55 degrees. So this is 28 degrees. And this one is going to be 55. Let's put it down here. Okay. So basically, and what they're asking in this case is how far apart are the towns? So we can say, well, the distance between the towns here is D, right? So again, remember, this is a chapter on right triangles. So we got to create right triangles. Now, there's a couple different ways we can create right triangles here. I showed in class using one way, so I'm going to do it the other way for the homework because I think either way would kind of work. You guys can see there's kind of two triangles here, right? And let's go ahead and just redraw this. So if I redraw these triangles, because I think this way is a little bit easier to visualize. Okay, so here's the kind of triangles, and let's just draw it again that size. So let's draw everything. Because one thing I said is like when these problems get tough, it's easy sometimes just to like redraw everything. So here's the two triangles, right? Okay, so how can we basically find the sides here of these triangles? We need to figure out basically the distance, which you can basically see is going to be the change in like how long this long side is of the big triangle and then minus that side of the smaller triangle. So basically, I need to be able to figure out like this side, D1, and this side, which I'll call D2. So the red basically covers the whole bottom side, whereas D1 and D2 just cover like these distances right there. Now, if this is 28 degrees, what we need to do in this case is use our complementary angles, because we know that this creates a 90-degree angle, right? Here is a 90-degree angle. So if from here to here is 28 degrees, then we just got to figure out, well, then what is it from here to here, which would be our larger angle. So I'm actually, you know what I'm going to do? I'm going to change the colors here because I don't have room to draw like two triangles. No, let's do that. Okay, let's try that again. There you go, perfect. Okay, so there's D1. That is, no. How did I do that? Okay, let me change that. Let's call that D. My bad. Okay, I'm making mistakes here. So let's do this again. All right, so we need to figure out that. That is our D. So let's call, this is what we're going to solve for. So that's our green. That's what we're trying to find. Blue is going to be D1. That's there. Okay, and then I'm going to do purple for D2. There we go. I messed up how the order of those. So D is what we're looking for. D1 is the length of the big triangle, and this is going to be the length of the smaller triangle. So from here to here, as we mentioned, is 28 degrees. So therefore, what do we got to add here to get to 90? Well, you just got to think about what would you add? So that's, if you add 60, that's 80 and 2, so that's going to be 90, right? These are complementary angles. So the blue angle of this is going to be 62 degrees. All right? And then for the purple angle, we basically got to figure out, well, then what is this angle? Well, if here is 55 degrees, what do I need to add to 55 degrees to get to 90 again, complementary? Well, that's going to be 35 degrees, right? So now I basically have these two triangles. I think I have enough room here. So let's go ahead and draw these two triangles again. I have big triangle and I have small triangle. So this one is 62 degrees. I have a right angle, and then this is my D1. And then for purple, I have 35 degrees. And this is a right triangle as well. And then this is D2, right? And again, guys, to find green, basically what I need to do, to find my answer, I need to subtract D1 from D2. So I need to do D1 minus purple D2. Now, the problem here is, what's really nice is I'm just going to keep these answers in my calculator. I'm actually not going to write these out. So I'm going to define what D is, but I'm not going to define D1 and D2 because I'm actually just going to use them in my answer. So I'm going to say, D equals the distance. What was the question? Distance between the towns. Okay, so basically, to go ahead and figure out D2, guys, all I'm going to do is set up a trigonometric relationship. And you guys can see here that this would be, oh, I forgot to, again, this is all 10, right? I forgot to write that in there. Don't forget that number. That's 10 kilometers, right? 10 kilometers, 10 kilometers, 10 kilometers. All right, that makes it a little bit easier. So therefore, you can see that this is going to be tangent. So I could say the, tangent, let's go a little bit lower. So the tangent of 35 degrees equals D2 over 10. And then in this case, I would write the tangent of 62 degrees equals D1 over 10 kilometers. Okay. And now basically, guys, I could go ahead and solve for D2, and that's exactly what I'm going to do. So when I solve for D2, I would basically get this. D2 is you're going to have to multiply, and so D2 is going to be 10 kilometers times the tangent of 35 degrees. And over here, you're going to have D1 equals 10 kilometers times the tangent of 62 degrees. So basically, to subtract them, I'm going to figure out D1, and then I'm going to subtract D2. So I'm just going to type this into my calculator, guys. I'm sorry, I'm not going to be able to show this. So 10 times the tangent of 62. And then minus 10 times the tangent of 35. And crap, that's not giving me the same answer I got here before. Tangent of 28. Why didn't I show it to those? That's 80, 90. Once I plugged it in. Tangent of 25 and 35. That's 80, 90. So that works. Let me just double check here. So tangent of tan 35. Okay, and tangent of tan. Oops. Let's store that. Oh, come on. I'm trying to see why I didn't get I got close to the same answer, but it doesn't seem like it's not exactly the same. So I'm not sure if I rounded incorrectly or what exactly happened. So let me actually just try it one more time. Tangent, 10 times the tangent of 62, and that gives me 18.8. So therefore, I'm going to store that as alpha A, and let's try it this way. And then I can do 10 times the tangent of 35. And that's 7, so let's store that as alpha B. So I can do alpha A minus alpha B. 11.8, that's so odd. So I got 62 and 10. And that's 28 and 38. So, well, I'm not seeing any work I did incorrectly. So unless anybody sees anything that I made a mistake on this problem, let me know. Otherwise, I'm just going to run with the answer that I calculated. I'm not sure if I made a mistake previously, but when I did this work, I just kind of like checked in some work, prior hand. So maybe I made a mistake there. So therefore, D is going to be 11.805 kilometers. So let me know if there's anything else that you guys have in there. And yes, Dolly, I am confused. I can definitely see this is a difficult problem. Like going from these problems, which are like fairly basic, you can see that this problem is a lot more confusing. And I did do it. The main important thing, guys, is what you have to understand is this has multiple triangles. So the main important thing is you draw the picture. You draw the picture with the triangles. And then basically what I wanted you to take away from this is you take the two triangles and you separate them. Then once you have the two triangles, then you create your trigonometric relationships. And remember, what we're trying to find is D. D is the difference from D1 and D2. So therefore, that's how I figured that out. It is a complicated problem. It's not something that is like the most basic here, for many students. But it is something that is going to, I think students need to make sure that they understand from there. All right, D1 is opposite, and K is adjacent. Okay, so I make a mistake on opposite over adjacent. Yes, that's right. So Guillermo, D1 is opposite. That is correct. Opposite over adjacent. D2 is opposite over adjacent. I'm assuming, I guess, I spoke wrong or spoke incorrectly, but I'm not seeing any mathematical mistakes. So let me know if there's a mistake. Yeah, I don't know. I got, I'll have to go and check, and, if there's any corrections, I'll go ahead and add it to the sheet. I'll go and check, and there's a couple different triangles you can look at, but I'm not seeing any other mistakes that I really made for the problem. So, I'm not sure where, what there would have been an issue, in for there. So Either way, well, I'll look at a couple of different problems after that. But obviously, guys, if you notice any mistakes or wherever I made it, let me know. Because I did get a little bit different answer, but I think it might have been a rounding answer from on there. All right, so let's go ahead and work on to the multiple choice. And Austin, I see, has a problem here for your homework. And what I'm going to do, guys, is, again, since I want to kind of speed through this, what I'm going to do is, rather than kind of taking a break or a longer break that I usually used to do between the multiple choice, I'm just going to go right through the multiple choice, and then I'll hang out here for the, I guess, I don't know, next 10, 15 minutes, see what we can do. All right, so, and then obviously if there's any questions on your homework, I'll go ahead and address them from there. So right now we have the perform the calculation, express the answer in degree, minute, second format. So you can see here, we have 94 degrees, 39 minutes, plus 11 degrees, and 50 minutes. So the main important thing, guys, we just need to remember is that there are, 60 minutes makes up a degree, right? So if we have, 60 out of 60 minutes, oops, yeah. 60 out of 60 minutes, basically that equals like 1 degree, right? There's 60 minutes in a degree. So what we're going to do here is, now I don't usually write this out from this case, but basically if we have 39 minutes, then we have 39 minutes, which is a part of a full degree, right? There's 60 minutes equals 1 degree. I'm actually just going to erase that because I don't think that's how I meant to write that. Okay, 60 minutes equals 1 degree, as well as, 60 seconds equals 1 minute. So therefore, we could also say 3,600 seconds equals 1 degree. All right. So anyways, when you have 39, when you have 39 minutes, we can write this as a fraction of a degree. So basically write it as 39 over 60, which is a fraction, right? That's less than 1 degree. All right. And then we just got to add that to 110 degrees, and then plus 50 minutes, which is, again, another fraction of 1 degree. Okay. So we can just go ahead and type that into our calculator. We don't really need to write the degree symbols, obviously just do 94 plus 39 divided by 60 plus 110 plus 50 divided by 60. Okay, and I get 25. So this gives me 205.4833, and looks like there's a couple more threes going on, right? So obviously that takes away our A and our B. Now the easiest thing to do is you could probably just check like 89 over 60, or 29 over 60, which one is going to give you that decimal equivalent of 0.48, right? Or what you could simply do is just take 0.48333 and times it by 60. Because again, that is how many degrees, right? You have 205 degrees plus this many minutes. So if you just multiply that, so if you just do 2.48333 times 60, what you get is rounded 29 minutes. So if you were to round that to 29 minutes, therefore you can see your answer D. I didn't really teach this in my class, so my advice to my students would just be, check which one of these, which one does that make sense? Does 29 out of 60 look like 0.48, or 89, out of 60 look 0.48? Well, it's kind of obvious. This one's not going to work. That's the only one that works. The next one is from the boat on the lake, the angle of elevation. So let's draw a nice little lake. Nice little boat. So the angle of elevation to the top of a cliff. So again, angle of elevation is going to be above the horizontal. Okay, so we're on top of a cliff. Is 35 minutes, or 35 degrees and 10 minutes. So let's go ahead and figure out what that is. So that's going to be 35 degrees plus 10 over 60. So let's do that. 35 plus 10 divided by 60. All right, so that's going to be a repeating decimal. So this is going to be very important. What I'm going to do is I'm going to store this in my calculator as A, and I really wish I could show you guys this, for those of you that are not familiar with that, but again, it's probably another quick YouTube search as far as storing angles. So I'm just going to hit store, and then I'm going to save that as alpha A. Okay, so that's stored. All right. And so instead of writing this out, I'm just going to say that's my A. That's a stored angle A. And this would be a right triangle. Angle of elevation is if the base of the cliff is 1,671 feet from the boat. So the distance from the cliff is 1,671 feet. Basically what they're asking is how high is the cliff? So basically we're looking for H. So if I was going to use a triangle here, I could say opposite over adjacent. So I could say the tangent of A is equal to H, that's a horrible H, over 1,671 feet. Okay, so all I'm going to do here is, just so you guys can see my work, I guess, H equals 1,671 feet times the tangent of A. So I'll do 1,671 times the tangent of alpha A. And I get 1,177, which is my answer B. All right, next one. It says a straight trail with a uniform inclination of 12 degrees leads from a lodge at an elevation of 600 feet to Mountain Lake at an elevation of 5,100 feet. So, all right, so a straight trail with a uniform inclination of 12 degrees from a lodge. So you have a lodge. So let's say here's the lodge, right? And has a 12 degree inclination, so that's going up. Okay, so there's your horizontal. And that's going to take you to a lake, which has an elevation of 600 feet. So again, this elevation is, the lodge has an elevation of 600. Like, let's say this is be like sea level then, I guess. And then it's going to take you to a lake, which has an elevation of 5,100 feet. Okay. And then it says, what is the length of the trail? So L will be the length of the trail. Now, again, the important thing to understand here is the height from the lodge to the lake is not 5,100, right? That length, or this height, is going to be 5,100 minus 600, which that equals 45, or 4,500 feet, right? Yes, yes. Okay, so therefore, looking at that triangle, I see that's 4,500. So now, if I want to figure out the L, I can see that's going to be my sine. So I could write this as the sine of 12 degrees equals opposite 4,500 feet divided by L, which we're trying to solve for. So really, L, when you try to solve for L, multiply by L on both sides, divide by sine, is really going to be 4,500 feet divided by the sine of 12 degrees. So since I'm not showing you typing this in my calculator, let's go ahead and do that. That'd be sine of 12. And I get 21,643.8. So if we round it to the nearest foot, that'd be my answer B. All right, last question. It says a radio transmission tower is 250 feet tall. So let's go ahead and draw that. So it's 250 feet. Cool. How long should a guy wire be if it is attached 10 feet from the top? So again, it's not all the way to the top, right? It's 10 feet down. So 10 feet lower. From the top, and is to make an angle of 22 degrees with the ground. So here, let's say that's the ground, so therefore that's going to be 22 degrees. Give your answer to the nearest foot. So again, what are we trying to do? How long should the wire be? So let's do L here. All right, so kind of the same thing here. Again, we just got to figure out what is this length. And again, guys, like the tower is 10 feet down, so therefore this is going to be 240 feet, right? So if I want to figure out what L is, because I'll use feet, if I want to go ahead and figure out what L is, then therefore I'm going to use sine again. So I'll say the sine of 22 degrees equals 240 feet divided by L. So opposite over hypotenuse, multiply by L, divided by sine. So L is going to equal 240 feet divided by the sine of 22 degrees. So let's go ahead and plug that into our calculator. Divided by the sine of 22. And I'm getting 640.67, which rounded would be D. So there you go, ladies and gentlemen. That is some word problems with trigonometry. Hopefully I got some good ones there for you. Notice again some ones where the sides are not as obvious as they sound. You got to kind of, read the word problems. Looking at ones, so these two were that sound. This is a very basic one. This is one just understanding degrees, minutes, and seconds, even though we didn't really get into seconds. Here's one where we're having some changing of, not changing angles, but we have more than one triangle. Here's an example of bearings and how to identify the bearing. Here's one where we're using our rates as well as being able to identify the different direct distances. And then here's just a very basic one as far as, creating that in. So hopefully that helped. Glad you guys, some of you guys are still on. What I'll do is just kind of check here. Check at the end. Maybe I can answer some questions here for you guys. And therefore, if you guys have anything else, I'll be happy to kind of answer your questions. So I see there's a lot of chat going on. Very cool for you guys. Yeah, sorry. I know there's just so many content for you guys that I have to kind of go through. So Austin, one question that Austin says, you're supposed to put it in slope-intercept form and then do, this is maybe getting back to somebody's question, which I think Austin maybe asked earlier. So, let me see, is there any questions that I can answer? I thought I saw something from Austin. You're just going to ignore this person. They reach out ignorant, trying to distract other people from learning. Oh, man, so much. Man, I guess all right, here's Austin. So can you help me work out this one math problem on substitution? Sweet. So I'll do a problem on substitution. That sounds like fun. Okay, so we have a system of 2x minus 4y equals 2, I believe, and then 2x minus y equals 2. Okay, so we'll go ahead and do that by substitution. Let's see if there's any other questions for on there. So, whoa, geez, all right. America, I have one. Awesome, let's do it. Tell me what you got. Dallas Farmer, you are very welcome. Attending that is a question. How you doing? I am doing very good. Austin, you have another question. Well, which do you want me to do? Both of them? I can do that one too. That's not too bad. Your second one. So y is equal to, I think, a positive 2x minus 1, and y is equal to negative 1. Okay. Brian, my question is, how was your day? My day was pretty good. Let's see here. What did I do? So I taught, obviously, in school, and then I had some students making up their test. So I stayed after and then helped some kids take their test. I also had some kids that came after for some extra help. And then I came home and got some dinner ready, picked up my girls, made them dinner, hung out with them for a little bit, read some books, and then I usually go and work. I usually try to work out after school, but in this case, I didn't have time from there. So then I went to the gym afterwards, and then I came back, and then I got to a live stream. So that's it. Now I got to still go ahead, and that's why I got to get off this live stream here fairly shortly, because I got to prepare for, not really prepare, I already have tomorrow prepared for law of sines, but I got to get their homework all set up and everything ready. So, all right, just the latest one, just the latest. Okay, so Austin, you don't want me to do this one. This was a good problem. I was excited to do this one. So if you don't want me to do it, let me know. I'll just do this one. But either way, that's fine. I'll just do this one. Unless you want me to do this one, because I'd like to teach that one. That'd be fun. But either way, or if anybody else wants me to teach that one, just let me know. Maybe give me a thumbs up, and I'll go through that one if anybody cares to know about substitution for that one. If anybody cares. All right, so let's go ahead and do this one since we are both. All right, sweet. I'll do both. All right, so let's do this one, and then we'll come down to that one. Yes. That's my math nerdness coming out. Because I'm probably only going to be able to work these two out, guys, to be honest with you. And America says what days you go live, so I'm going to go crazy. All right, so I got another one, the graphene 3 raised to the x minus 2. Okay, I'll go ahead and cover that. America, I'll cover that one as well. All right, Guillermo. Dang it. All right. Why do you guys always get the questions coming in? So anyways, I'm not doing any more questions. I got Guillermo and America. I will do those questions, and then that is going to be it. So if you answer any questions, I'm sorry. I'm just not going to be able to get to it. But anyways, let's 3y minus. So anyways, my goal here is to start doing live streams on my goal is to start doing live streams on Tuesday and Thursday at 9:30. So what I'm going to do is, again, if you guys are interested in that, I will try to put them on YouTube as early as possible. But I'd really like to do, as far as any questions that you guys have, is for you guys to go ahead and post those either on Facebook or on my, if you're part of my YouTube memberships, then you can post it there as well. So therefore, I kind of know what kind of questions, and I can make sure I get them addressed for you guys. Okay. All right, so I'm going to do that. And Gil, you just want me... This is a linear quadratic. I'm not seeing where the quadratic, though, is. Okay, so you guys are doing linear and quadratic. I'll just do the... Okay, cool. All right, so either way. So let's go ahead and one by one. Let's do this one because I think this will make sense. So I'll do this one first. All right, I got 12 minutes. I can do that. 2, 3, 4. Okay, question number 1. We got to find substitution. All right, now the main important thing, guys, when you're doing substitution is basically plugging one equation into another equation. All right, and I think the easiest thing to do for substitution, or only to do substitution, is when you have an equation isolated. So you can see, or when you have a variable, x or y, or whatever your variables are, that has a 1 or a negative 1 in front of it. So you can see in this case, this y has a negative 1 in front, right? Because if there's no number in front there, we can assume it's you know, a 1 is there. So typically, that is when the math is going to be the easiest. So what you're going to do is you're going to take that equation and you're going to solve for y. Okay? So obviously, this one is going to create a little bit of work here. So I have negative y equals a negative 2x plus 2 divided by negative 1 divided by negative 1, and I get y is equal to a positive 2x minus 2, because that negative 1 divides into both of those, okay? Now, you don't really need to do this, but I'm just going to rewrite the system here and just write 2x minus 4y is equal to 2. And then y here, right? So now I'm going to say y is equal, and I'm going to use green here, to 2x minus 2. So again, like, understand this. So what I did is, all I did was I changed, so that remains the same, but now this has changed, right? 2x minus y, right? We changed this to y equals 2x minus 2. Same exact equation, you just moved it around. The important thing that's going on here, though, is now I have this variable isolated, right? I have y isolated. So when I read this equation, 2x minus 4 times y, well, 4 times y, what does that mean? Well, what does y represent? Y represents 2x minus 2. So what I can do now is I can rewrite this whole equation, this expression, as 2x minus 4 times y. Well, again, what is y? Y is 2x minus 2. And then, therefore, that's equal to 2. Okay, now we just need to apply distributive property and then solve for x. So 2x minus 8x plus 8 equals 2. Let's see, that's going to be a negative 6x plus 8 equals 2. Subtract an 8, subtract an 8. Negative 6x equals negative 6. Divide by negative 6, divide by negative 6, and x is equal to a positive 1. Okay, so now we know what x is equal to, and again, we can kind of follow like the same logic. If this equation is y is equal to 2 times x, again, what does x represent? It represents 1. So just plug a 1 in for the x, and now you can solve for y. 2 times 1 is 2, 2 minus 2 is 0. So therefore, you have y equals 0, x equals 1. So you have a system of equations with two unknowns, which are x and y. And then by using the substitution method, we're able to evaluate for both those points. You could write the solutions like this. Sometimes you might need to write them as a solution or a solution point. Either way, it's kind of the same idea. All right, so that was number 1. So number 1, I think, was the hardest. Like, at least required the most amount of work. Number 2 can be confusing for a lot of students, because you have two variables that are already isolated. But really, mathematically, this one's pretty simple. And I think what also helps with this one is, remember guys, when we're solving systems of equations, we can do that by graphing as well as using the algebraic method. Let's just go ahead and graph this. If I was going to graph y equals negative 1, that is a horizontal line at negative 1. If I was going to graph y equals 2x minus 1, the y-intercept is negative 1, and then it goes up 2 over 1. So just by doing this, I already know the intersection point. The intersection point is 0, negative 1, meaning x is going to equal 0 and y is equal to negative 1. So just by doing a quick sketch, I get it. All right? Now, let's use some color codes instead. Let's let y, I'm going to do a different color. Let's let y equal negative 1 in green. Okay? So what that means is, again, y equals negative 1. In this equation, y equals 2x minus 1. Well, again, couldn't I just replace this y, like with that y, and that green y is actually equal to negative 1? Meaning, I could really just write negative 1 is equal to the blue, other blue, which is 2x minus 1. And now, when you go ahead and solve, add 1 to both sides, you get 0 equals 2x. Divide by 2, 0 equals x. And then again, you don't need to plug that back in because it already says y equals negative 1. So x equals 0 and y equals negative 1. Done. The next one, number 3. Again, another systems of equations. But now in this case, so you have 3y minus 3x equals what, 3? Yeah, and then y equals 9 minus 3x. Okay, so again, guys, we understand what y represents. Like, y is isolated in this problem. So again, what I'm going to do is I'm just going to redraw everything. I'm going to say, all right, well, 3y, actually, let's do it this way. 3, let's make y in purple. 3y minus 3x equals 3, where y is equal to 9 minus 3x. So again, guys, like, here's y, right? 3 times y minus 3x equals 3, and then we already know that y is equal to 9 minus 3x. So to solve for my x and y, I can replace my y with a 9 minus 3x. And that's going to be minus 3x equals 3. Okay, so then I go ahead and apply distributive property. So that's a 27. That's a negative 9x minus 3x equals 3. This becomes a 27 minus 12x equals 3. Subtract a 27, subtract a 27. And therefore, negative 12x equals a negative 24 divided by negative 12 divided by negative 12. X is equal to a positive 2. Okay, so again, we know x is equal to positive 2. But again, what we can do is go back to our equation. Y is equal to 9 minus 3 times x. But again, what does x represent? X represents 2. So go ahead and plug it in there, and we get y is equal to 9 minus 6. So y is equal to 3. All right, my hand is starting to hurt. But I did say I'll do one more question, so I am going to get on to that last one, okay? All right, so last question is graphing y equals 3 raised to the x minus 2. And then I think minus 3. Okay. All right, so there's a couple things you need to know. So this is an exponential function, which is in the form, let's use red here, of y equals a to the x. Or actually, we use b, right? That's, I think, the b to the x. Okay, so we got to remember, like, the parent function here of that graph looks like this. Crosses at 1. So it crosses, has a y-intercept at 0, 1. Okay, and then also has a horizontal asymptote at 0. Okay, so sorry about my horizontal asymptote, but there you go. So that's the parent graph. Now, the only difference here is, b, it doesn't really matter if b can't be 1, but if b is like 4 or 5 or 10, like, it's still going to take the same shape, but basically what that's going to be doing is that's just going to kind of like stretch the graph higher or lower, okay? So the value of 3 actually isn't affecting the graph. I mean, it is affecting the graph, but it's not going to be, you're not really going to be able to, like, change that formation, or at least when I'm telling students to graph these, I'm like, don't so much worry about the base. Yes, that does affect the shape of the graph, but it doesn't make that much of a difference on the graph that, it's really going to be something, like, you're not going to really be able to notice 3 compared to 4 as far as the base. However, for our transformations, though, that does make a difference, because when we look at this as far as in terms of transformations, we have y is equal to a times b raised to the x, and then there's a couple different ways you could do this. We could say, minus c plus d. Okay, so hopefully, if you're an exponential, you have already covered transformation. So like, for instance, like on a quadratic, y equals a times x minus, I'll just do h squared plus k. Right? That's your vertex form. So remember, A is shifting your graph, is opening your graph up or down. It's also vertically stretching or vertically compressing your graph. H is shifting the graph left or right. K is shifting the graph up or down. Well, C and D are really doing the same transformation. C is shifting your graph left or right. D is shifting your graph up or down. A is reflecting your graph up and forward and back. And there's obviously another transformation, which is the other reflection, but just to kind of save myself some time, we're not going to go through that. So again, this is not going to be an effective transformation. This is really kind of like a stretch. So what we can see is there's basically 2 transformations. We're shifting the graph, x minus 2, just like in a quadratic. If I had x minus 2, I would shift the quadratic 2 units to the right. And if I was subtracting a 3, I'd shift the graph 3 units down. Well, that's really what we're doing here. So you're taking this graph, this parent graph, and you're going to shift it 2 units to the right and 3 units down. So let's think about that. If I was going to take this graph, take this point, and if I was going to move it 2 units to the right, this new point would be right here. And then if I shifted it down 3 units, it'd be 1, 2, 3. If I shift this graph left or right, the horizontal asymptote doesn't change, but the vertical asymptote does go down. So now my vertical asymptote would be at -3. And then my graph would go like that. So I usually just tell my students, just give me a rough sketch here. Make sure you can maybe give me like a coordinate point so I can see that you, at least have one point, correct, and that's what we'd be there. So there you go, ladies and gentlemen. That is at least an hour, so I did not meet my 45 minutes time frame, but I don't know. I had a little fun. It was a good time. Hopefully you guys enjoyed it, and hopefully I also helped you guys out with some different ones. I will plan on be going live next Thursday at 9:30, so definitely plan that out. And again, you guys can obviously, if you haven't already subscribed, that will let you know when I go live, or if you click the bell. I am obviously going to point also also take these solutions and everything else and put them on my YouTube membership. So if that's something you're interested in, you can feel free to check it out. And otherwise, because that's what basically I do these for my students, and as well as for those of you out there that need some extra practice on so on and so forth. So hopefully all of this has helped you guys out, and I look forward to checking you guys out on the next live stream. All right, I am out of here.